For this next lesson, we are going to continue using win over possible as we go through these here. But our objective for this one is to compute conditional probability using a sample space. When we talk about conditional probability, we are going to change up the way that we've been looking at some of these problems. And the best way to go about this is to just go through an example. We have a deck of 10 cards that are numbered 1 through 10, as you can see below. Some are gray and some are white. We need to answer two questions, and we're answering both of these questions as a fraction, it says. So we're going to make sure we do that. Our final answer should be in a fraction. It says a card will be drawn at random. What is the probability that the card drawn is white? So I'm going to put A here. I'm on question A, so I'll put the A there. What is the probability that the card drawn is white? Well, out of the 10 cards, again, I'm using win over possible. I see 1, 2, 3, 4, 5, 6 white cards. So any of those would be considered a win. We have 6 cards, the 2, the 3, the 4, the 6, the 7, and the 8. Those 6 cards would all be considered wins. Well, how many cards are possible to be drawn? We have 10 possible cards. So we have 6 over 10. I'm going to make sure that I simplify my fraction, even though the question doesn't ask us to, I will. 3 over 5 is how I'm going to put my final answer there. Let's move on to question B. What is the probability that the card that is drawn is white, given that the number drawn is less than 9? So now every time you see that word given, we're basically assuming that something has already happened. When we say given that the number drawn is less than 9, it's basically a guarantee that the card that we draw is less than 9. That means we don't include 9, so it's got to be less than 9, strictly less than 9. So that means the 9th card and the 10th card are no longer in play. What is the probability that the card drawn is a white card, given that these 2 cards are not in play anymore? Well, let's talk about how many white cards there are first, again, because that would be considered a win. 1, 2, 3, 4, 5, 6. Still 6 white cards on the board. How many cards are there total? Well, I see 8 cards still left there. Notice between A and B, my two answers are different. One was 6 out of 10, and one of them is 6 out of 8. That's because we took 2 cards away. If we simplify this, we'll get 3 over 4. That's it. Let's move on to the next one. This is a spinner. We have 10 equally sized slices, numbered 1 through 10. Some are white and some are gray. The wheel is spun at random and will stop at a slice at random. What is the probability that the wheel stops on a gray slice? So just from the beginning here, again, we're doing win over possible. For A gray slice. Well, a win would be considered a gray one. So we have 1, 2, 3, 4, 5, 6 gray slices. How many slices are there total? I can see 10 numbers, so there must be 10 slices. We can simplify that as well. That'll be equal to 3 over 5. And we're on to question B. Question B has a given again. So it says, what is the probability that the wheel stops on a gray slice, given that the wheel stops on a number that's, again, less than 9? Less than 9 does not include 9. When we say the word given, it means it's definitely going to happen, that it's less than 9. So basically 9 and 10 are taken out again on this problem. So now you can think about it like this. It's basically an 8-sliced wheel, which means, well, first of all, let's see. It wants a gray slice again, so a gray slice is still a win. We still have 1, 2, 3, 4, 5, 6 gray slices. And this time we only have 8 slices left. that must mean my final answer simplified would be a 3 over 4.